Hey everybody, thanks for tuning in to episode 87 of the Social Media and Politics podcast, bringing you expert insights into how social media is changing the political game. I'm your host, Michael Bucetta, political scientist at Lund University. Connect with the show on Twitter by following us at SMNP Podcast or visit us on the web at socialmediaandpolitics.org. All right, y'all, thanks so much for tuning in. In this episode, we're going to be totally nerding out around data and computer science and looking at how natural language processing can help us study social media in ways that tell us something broader about politics and society. And my guest, who's well positioned to do just that, is Dr. Leon Derczynski. He is an assistant professor in computer science at the IT University of Copenhagen. And in this interview, we're going to dig into some of Dr. Derczynski's research projects, which builds computer systems that can, for example, detect the level of informativeness in tweets in order to alert first responders around crisis communication, or looking at conversation patterns in comment fields to detect whether a claim is true or false. This is all possible with natural language processing, and I know it's a very esoteric and nerdy topic, but it's one I think is fascinating, and I know that there's some listeners out there who are doing data science and are very interested in this type of work because you do it yourselves. So for the broader audience, I think it's really interesting to understand how we can automate processes that tell us something from social media data in a way that informs our understanding of politics, or even how humans communicate at a more broad level across languages and across different cultures. So without further ado, let me turn it over to Dr. Leon Derczynski. He is an assistant professor in computer science at the IT University of Copenhagen. Dr. Derczynski, thanks so much for taking the time out, and welcome to the Social Media and Politics podcast.
Hi, not at all. It's my pleasure.
So why don't we start a bit with your academic background, and how did you get into computer science?
Computer science. All right. I guess it's one of those things, I think you see it a lot in applications from students and things, right, where it just seems something really easy during your childhood. So you do that, and people seem pretty excited about you doing that, so you carry on doing that. Yeah, I guess I was just kind of good at it, right? As it seems, anyway. And it was going places, so it was easy. And then through my bachelor, I did software engineering. Thought it was a good career in this, but then I took a couple of years out and I worked in that, and kind of came back and thought, all right, that's enough of that. I guess we're not going to do this anymore. Switched over to computer science. And in that time out, I'd been working for one of the UK's top digital marketing agencies, Summit Media. And we'd done a lot with language, a lot with optimization for the search engines, that kind of marketing stuff, you know. And the language kind of part was really, really fascinating. So I got back into this at Sheffield and haven't been able to get out since, I guess.
That's funny because I wanted to ask you, we'll get a bit more into the nitty-gritty of computer science as we go along. But especially since you worked in industry, why did you move from industry into academia?
So the bit that I was having the most fun with in industry was the research, right? That was like finding out how things can be really done, how we can do things better, and how we can solve some tough problems like understanding text and language. And every time I was in industry, I mean, the coding stuff, that was fun. And you'd learn how to manage code, right? Which is a really important skill I think a lot of researchers are missing these days. But I kept coming back to these problems. So, I mean, the work wasn't so satisfying. I remember my boss, when I said I'm going back to university, he was very disappointed. He was like, well, we were going to offer you this job and this. And yeah. All right, that's cool. And I'm sure you'll find someone who loves it. But I was too fascinated by those problems. I couldn't get away from them.
Mm-hmm. And I mean, are you looking particularly at social science questions? Or is it computer science broadly into whatever you're needed in whatever research group?
Oh, that's a good question. So the most meaningful questions for computer science tend to come, for me anyway, a lot out of the world around us, right? Like I see computer science as providing tools rather than a means in and of itself. I remember the head of department when I was at Sheffield, Yorick Wilkes, kind of the grandfather of computational linguistics in the UK, would often interrupt a lot of talks with just hasn't this been done in the 60s or 70s, fish out some obscure reference. And he'd be right to a large extent. And I think a lot of those research questions kind of have been done not only in CL, computational linguistics, but also in computer science overall. A lot of the fun stuff, I think, was solved in the 60s and 70s. So now we've got that basis of solutions, that technology. We should go out and try and bring it to the rest of humanity, right? Try and find some problems we can engage with. And social science has a lot of awareness of what those are.
Yeah, especially with the arrival of digital media and social media, which I know you work a lot with and we'll get into. But can you describe what type of methods that you actually work with when solving some of these social science questions?
So usually we take, we have this kind of tough thing, right? When we're dealing with text on a computer, really we just have this sequence of bytes, right? Like a list of numbers. And somehow those meant to represent information. First, you have to convert it to maybe some letters or characters in Chinese. So you get some kind of script out of it. Then that's got words. And you have to work out how those words link together. And so there's a long set of processes to get to representations of text. And there's a lot of discussion about how we can do that best, and it's moving very quickly. But really, once we have those representations, I mean, so now you've captured a bit of that knowledge that's in the language, and you've got it on a computer, and now you can process it. So we use a lot of machine learning methods. I guess the headline word for that these days is artificial intelligence. And when artificial intelligence goes out of fashion again, we'll just go back to calling it machine learning.
Do you think actually that machine learning is artificial intelligence? Because I'm curious to ask a computer scientist this question because, I've seen some digital marketers, for example, say we're using the latest AI technology because it's kind of a sexy word. Is machine learning actually artificial intelligence?
Is machine learning artificial intelligence? That's a good one. I remember, so you've got this nice point about how sexy it sounds. I remember I was down at Roskilde, 2010, first and only visit, stayed all 8 days, never, ever again.
This is the festival or the city?
Yeah, the festival. Yeah, I mean,
Okay.
I don't regret it, and that's enough.
It's a big music festival in Denmark.
Yeah, exactly. And so you got these kids, I guess, maybe like 18, 20 years old from Norway coming along and say, hey, what do you do? And you're like, well, I work in AI. And then you realize if you say AI instead of machine learning, they just go, cool, that's great. And they have no further questions and you're out. You're out of that. I mean, it could be... So for me, I find it pretty difficult to define what is intelligence and what is learning, right? And we don't have a good definition of when we've achieved that artificial intelligence or whether or not we can detect a human as intelligent, for example. I mean, the best test that we have these days is still the Turing test, which formulates intelligence as something linguistically defined, right? So the Turing test, for background, is where you're in a situation where you're typing through a terminal to communicate with another human or another machine. And you've got to try and tell the difference between human and machine. And if the machine can trick you into thinking it's human through a lot of very clever questions, then we say it passes the Turing test.
And I mean, reading some of your research, you do a lot of natural language processing.
Right.
And so why is NLP, in your view, a useful approach to study social media data in particular?
Well, I say it's the thing with language is like we can get a lot of information onto a digital format, but everything that doesn't fit in the form, that's expressed in the language, right? You look at clinical data and you can pick the medicine from the drop down and get the patient's details from some table somewhere. And then the rest, like, well, this is what's going on in their family and that's why they might have a condition, that has to go in the text. So all this information we can't represent in forms just spills over into language because that's kind of how we're used to storing all these things. So processing language, that's where we're going to find most of the information, right? That's all the information we don't have in forms and things already. That's where everything is. That's kind of how people communicate, right? Mm-hmm. I mean, I like to see social media. It's like this, it's like a sample of all of human discourse. Like it tells you a little bit about what everyone is doing. And sure, there's bias, like people who don't use the internet, they're not represented, but you can measure that and you can correct it. But we never had this before, right? We never had like a little book where it just wrote a couple of sentences from every city in the world every day. That's magic. So this tells us just so much about humanity and the information we exchange and every problem we're trying to solve.
Yeah, totally. And we'll get into some of the perhaps political implications of that in a second. But first, I have a question along the lines of this AI machine learning. I guess questions of language at the end of the day. Why exactly is natural language processing natural? Because I've always wondered, it's the machine that's doing a lot of the processing. So where does the natural, what's the natural part?
Oh, nice. All right. So I guess that depends on where we break up this compound noun, right? So we could is the language processing natural? But actually that's nice. Yeah. I guess humans are doing like language processing naturally. Mm-hmm. So it's really meant to be processing of natural languages, but because we're putting it in front of computer scientists, we've got to be like, it's not a computer language. If you can imagine this computer scientist, they say they do language processing. There's a big chance you're going to think they just spend all their days filling out punch cards with assembly language or C or something like this. I don't know, something a lot less fun than natural language anyway.
All right, so let's move into some of the core aspects of your research, which a lot of it has been focused on information extraction, particularly on Twitter. And so in the political sciences, we generally think of Twitter as the platform with the most information, looking at journalists, politicians, versus, let's say, Instagram, which is probably less political. So why is information extraction important? And why look to Twitter as a site to extract information?
Two good questions. So information extraction is it's really broad. It can mean any kind of information that's represented in text. So it could be like one classic example is what they call the slot filling task, right? And it's like, imagine you've got a topic, maybe University of Copenhagen. Let's make that our topic, right? If you look at Wikipedia, you get those little info boxes, right, up in the top right. If we're in left to right language, and it has all those little slots, all labeled and a bit of information. So these, we try and extract these from just text, right? And this is the slot filling task. Here's a news article, pick out information about University of Copenhagen. So this was like a basic information extraction thing. But you're right. I mean, there's so much more in this, right? We can apply it to politicians to think about, well, what is politician X's opinion about Y? And what cities do they like to discuss? And where do they, and kind of where do they talk about certain things? Because we have their location as well from social media. Yeah, that's kind of the information extraction thing. Can you remind me the second part of the question?
The second part of the question is, why look to Twitter as a site to extract information?
Oh, right. So this, there's kind of a bit of a licensing thing going on here, right? So Facebook is getting progressively more and more and more closed. It always has had the most restrictive privacy when it comes to text. If you're an outsider, I don't have that Cambridge Analytica budget, so I'm an outsider, right? So this is really tough to get at. Instagram, we can get a bit of traction with, but it's not so popular in many places. Whereas Twitter is pretty easy to get text off. And kind of the default with Twitter is that something's publicly available, right? So you just, you publish and it's out there, which makes distribution and collecting the data really easy. So this ease of being able to collect tweets just drives research naturally there. We don't have to wait 6 months for some application to go through with Facebook yeah. The other thing is, from a research point of view, Twitter is super interesting, especially in the old days when they had just 140 characters, because this kind of constraint, this format, would generate really weird language. Like you'd see people shortening words, picking weird phrases, using all kinds of non-verbal expression, right? Like LOL or SMH, and this kind of probably showing my age because I don't know the cool ones. No, the sad thing is I have a catalog of them. But we have all these ways for people trying to get this really rich person-to-person communication with all their hand gestures and everything they're doing with their face, and they just got to cram it into 140 characters as well as their text. So they bend language, they get really creative, they do all this peculiar stuff, and kind of you'll see every individual expressing themselves just as they would do person-to-person, but in 140 characters. So the text was super hard to process. This was like we're putting NLP onto maximum difficulty mode, right? So that was one thing. And then digging a little bit deeper, we realized the reason it's difficult is it's because it's blended with so much sociolinguistic information, all about the demographics, the opinions, the situation, the kind of interaction of the person typing. Mm-hmm. So this became just even more interesting.
Yeah. And I mean, let's zero in on some of the research that you've done. And one of your projects you've been a part of is looking at crisis communication.
Right.
And there, I think Twitter fits really well because if there's a crisis, you want to go through something that has low algorithmic filtering. Twitter's your place to do that. And so getting to this idea of information extraction, you've been trying to kind of extract and measure the informativeness? Informativeness. Informativeness.
Maybe I'm going full British.
That might be a British American thing. So informativeness of tweets. How do you actually, in the context of, let's say, wildfires or just recently had an earthquake in California, how can you sort of monitor and pull out the informativeness of tweets?
That's a good question. So the first thing you got to do with this is get the tweets, right? To process all of Twitter is kind of usually unhelpful, right? For example, with the California earthquakes, most tweets won't be about that. So you don't monitor all of it all the time unless you have huge amount of resources. So for a while, we were kind of in this ghoulish mode where we'd be following 1%, 10% of tweets all the time. And then as soon as anything happened, we'd set the systems to save what they had and chuck in a bunch of hashtags. We'd set up searches and cataloging for all of those things through this company, through Atos, a big European software provider. And it was kind of this ghoulish exercise, right? Someone's died, so we need to react and capture all the data about that. But then we had a good data set, right? So that's okay. And another good data source that was really helpful was Jason Baumgartner. So he's working for this company, PushShift.io. Well, actually, he owns it. It's his concept. And this is just really good at capturing and logging any kind of crisis or political-related data out there on the web. So this has been a great source. But even when you've narrowed down your search to messages you think are related to what's going on, still, you don't want to report all of those to a crisis response agency. And that was who we were working with in this Comrades project, this EU Horizon 2020 project. We were working with these response agencies and working out how to use that community resilience that you get from a social media platform in these disasters. So we would have to go through and kind of work out, well, first you need to define what is informativeness, right? And I think philosophically, this is a really tough thing. Like, what is saliency? What is informativeness? And it's so subjective, right? And it's going to vary over time. Something might be very uninformative today, but we might find out it was crucial in some events that we would only know about 50 years in the future. So it needs to be pinned down. Luckily for us, we had this really cool, well-defined, crisp scenario for crisis response where we would know exactly what kind of actions we could take. I say we as maybe imagining myself as a crisis response agency. So what actions could be taken, and then what would be interesting, what could be responded to, is there feedback on our responses? So we had this kind of schema that came from blending up a few universities and a few response bodies, kind of definitions of what would be useful in a crisis. There was one from a project at MIT, and there was another one with the UN, another one with the Red Cross. So we looked at all these things and thought, where can we define what's informative? And then once we have a few of those definitions, we can lump them together. And then we do the normal machine learning thing, right? Which is where you label a bunch of data, informative, not informative, and then train a classifier, some kind of system to pick out that data, and then we'd run it over what we captured.
And it's important, I think, to note that it's, you're using humans to classify that data first. And I have the luxury of having the computer in front of me where you define informative as the information in the message would be helpful with saving lives or assisting the authorities / other response teams in dealing better with the incident. And then you send this out to people to code and then use that to train the machine, right?
Right. With most artificial intelligence, you need some human intelligence to start with, right? Mm-hmm. And then you try and encode this. So this was a task where getting that encoding done, we like to crowdsource a lot of our data because academics have a very narrow field of knowledge, right? There's this little example. We were trying to just label named entities. Those would be people, locations, organizations. And someone would say, there was one little tweet that said KKTNY in 45 minutes. No academics know what this means, right? But you take it out to the crowd and instantly people put up their hands and say, yep, I know about those Kardashian sisters, right? Let's go. To academics, we can't do it. But so for this, we had some people who've been working in crises and a really well-defined schema of what would be informative. And then we would use this to help code those tweets for the training data. And doing this, so for this exercise, it wasn't so tough, but you find all those edge cases of what might or might not be informative. And sometimes these documents can get up to like 70 pages of just edge cases, just working out A or B, right?
Mm-hmm.
Yeah.
Yeah, and I think from one of your papers, you were saying that humans are very good at classifying kind of binary categories, but are bad at 7 or above.
Right. So that's not my finding, but that's certainly something we use all the time in our work. Yeah, when you give people a whole bunch of choices, it's kind of hard just to cognitively manage and pick reliably between those. You've got to really narrow these down.
Mm. So you mentioned this just a second ago, but I wanted to ask you about named entity recognition and named entity linking. What are those concepts?
So the idea with this comes originally actually from DARPA projects, I think back in the Cold War days. And they wanted to go through documents and pick out mentions of important information like actors or facilities or weapons, this kind of thing, right? But so this isn't kind of how we use the task so much anymore. It's kind of grown and been taken broader, just like the internet, I guess. In a text, you want to pick up the mentions of people and of organizations, and of locations, typically. It could be broader. Maybe if you're doing business intelligence, you care about stocks and products and market moves and tendencies. But some things will have names. So an example of a named entity would be like if I say Copenhagen instead of the capital of Denmark. So in this case, Copenhagen is referred to by name and it refers to just one thing, hopefully. We'll get back to that in the second part of the question. Whereas if we say the capital city, we don't give a specific name for anything, right? So that's an entity, but not a named entity. So that's cool. So we can pick out these, and maybe we find our document says, well, there was a shooting in downtown Paris, right? So we can recognize this named entity Paris, but we don't know which of I think there's 17, 20 Parises in the world, right? We don't know which one it refers to. Is it Paris, France? Is it Paris, Texas? for example. So named entity linking is where we take this mention of a named entity and try to link it to a place where it's unambiguous, like Wikipedia, right? We can just link that to one Wikipedia entry, and then we know it's Paris, France, in this case.
Because I think they can be quite crazy, these named entities. And I think my favorite example is the one that you write about with the Russian Navy.
Oh, the Russian Navy.
Was this a real tweet?
Yeah, that's all real.
Okay, so I'll just read it out. So you write that many named entities are used in unconventional ways. For example, in the tweet, quote, branching out from Lincoln Park after dark, hello Russian Navy, it's like the same thing but with glitter. So in this case, Russian Navy doesn't refer to the Russian Navy, it refers to a nail varnish color, which, I think is super interesting that, if you're the Department of Defense and you're monitoring the Russian Navy and Kim Kardashian tweets about how she loves the nail varnish, then you're going to have this explosion, this spike in activity about the Russian Navy, but it's referring to nail polish.
Right. It's cute, huh? Pretty tough. And then, maybe the Russians are interested to see why we're talking about their Navy with glitter on. Can be a sensitive topic for them. Yeah, it's really tough, right? And people leave things underspecified as well. And especially, so we did a bit of this work. Being in Copenhagen, you work with Danish, right? And with Danish, it's even tougher just because there's so much less diversity in names. Like if you were talking about a Morten Larsen, I think there's like 10,000 Morten Larsens in the country, right? So then it's really hard to link it properly.
Yeah, and I think the Danish language, I think the same for Swedish and Norwegian, actually doesn't have a lot of nuance. There's not a lot of numbers of words. So they have, I don't know how many, let's say, for example, 10,000 words, whereas English might have 100,000. So there's 10 different ways to say the same thing.
Yeah. And this is all different with different languages as well, right? You'll find not every language can cover all the concepts. We don't have a word in English for the back of the knee. All right, we're missing that, right? What is that? Tons of languages have it, though. But we just can't map that into... Well, there's another one in Danish that have this idea of an overskud, which if you saw the spelling, you would never guess the pronunciation. But it can mean a profit, but also like how much mental cognitive energy you have at the end of the day, or just how busy you are. And so if you don't have enough of this, it's really common just to say, I don't have enough overskud, and the other person understands, okay, I shouldn't give them any more work, I'll just leave them to it for a little while.
Like bandwidth.
Oh, all right, this guy. Yeah, okay.
No, I get you, though.
Yeah.
So I want to ask, we know that many political campaigning and government institutions have these media monitoring teams or these subscriptions to companies that are specially designed to do media monitoring. So my question is, how do you think NLP methods might differ from these type of broad stroke media monitoring platforms? Or put another way, what's the benefit of an academic approach to social media data versus the more industry-oriented media monitoring?
So I guess in our field, the line between academic and industry is paper thin and very permeable, and people go both ways. Even an individual cross back and forth in the same career these days. So don't know, but everyone needs research, right? You've got to be at the forefront. Your competitor will be, even if your competitor might be another university or the company just on the next block, right? But they're all using pushing forward and trying to get those higher accuracy scores, better customization to what their clients need was the next step. And being able to do it cheaper, right? Data scientists are too expensive these days, for sure. Maybe I'll just kind of rotate the question a little bit and say, if we use NLP to do media monitoring, what can that bring compared to a more classical approach? It can be quite quick. You can automate a whole bunch of stuff and you'll get a lot of detail. You'll be able to connect things between stories, between outlets that weren't feasible to do so well manually. And you can pick up and filter things really quickly. And then we even have these... So there's a little bit of attention now about framing, which is a very well-known thing in at least journalism, discourse analysis, how you frame an issue, what you say, what you don't, and the language you choose to describe it, right? Are they illegals or immigrants or foreign workers? All these different framings. So there's been a lot of work in NLP in automatically detecting framings. And then you can use, once you have that automatically detected frame, you can kind of apply that to everything you see just to see what matches it, right? So this is really nice for spotting manipulation or hyperpartisan news. You kind of automatically detect that quite extreme or directly false framing. And you can pick that up in new outlets, new articles as they emerge without anyone having to look at it. So I think the things that can be automated are pretty sophisticated these days. And once it can be automated, it can be scaled out. The thing that, I mean, of course, there has to be this word of caution, right? Even if it was as good as human intelligence, the AI, it would still make mistakes, right? Just because it's running really nicely and it's looked okay in the past, and now it's processing millions of stuff every hour, still got to keep an eye on that and check for the results.
Yeah, because I think it's this kind of cat and mouse game between the bad actors and then the media monitors. But this leads very well. I wanted to get to challenges to NLP, but let's do that last. I want to talk about veracity and the, how do you say it? Theme project?
Theme, yeah.
Theme project, which is interestingly theme, or I think I was reading a little bit into this. It's a Greek goddess.
Right.
Which I think is pronounced Fame.
I think so too.
Which is funny because a lot of people used to call memes Maymays. But anyways, so she was a goddess of both fame, but her wrath would be the spread of rumors.
Right.
So this is an interesting project. It started in 2014, which was way ahead of the whole disinformation phenomenon, right? So we were talking about information extraction, but that doesn't take into account, I think, whether that information is true or false. And I think that's what the Theme project does. So can you kind of describe that project and what you were trying to do there?
Theme. Yeah, you're right. I mean, so we're trying to address this idea of veracity on the web, right? Which seemed just like every academic research project, kind of esoteric, maybe unnecessary, a bit, if not very eccentric at the time. We were like, well, there's stuff on the web. Some of it's true. You know which sites to avoid. We have Snopes. Why bother? And I think now we kind of have a much more deep understanding of why that might be important, right? I mean, we've seen people are now aware of news manipulation, this kind of thing. But so when we were building this project, and I guess we were kind of writing the proposal in 2012, 2013, it just seemed like it was this big gap in research, and we knew that false information would harm people, right? So we'd had a couple of use cases in this. With every project, you have to find some way of, well, I mean, for us, I think it's much more useful if you can demonstrate the impact it might have and evaluate in context. So we took for this one, we took the medical context and a journalistic one. So we're working with the biggest NHS trust, which is like the biggest NHS area in the UK, which was South London and Maudsley. We're working with them through KCL, mostly researchers down at King's College London, for the medical stuff. And then for the journalists, we're working with Swiss Info. So for the medical things, we knew like there was a big controversy about whether aluminum. Mm-hmm. All right. Yeah, if this in the water would create or accelerate Alzheimer's disease. So there was a lot of information going forth about this. And then there was of course, there was the NMR fraud, where the guy was saying the vaccine for measles, mumps, and rubella would lead to autism. And he got a few papers, and then he got in so much trouble and, of course, admitted that he would fraudulently publish those papers and retracted the whole thing. But people still are kind of believing this story from his from the 80s and 90s, which means they don't get vaccines. And then that means that they die from measles every now and again. So we knew there was direct harm, right, from this veracity problem. So we thought, I mean, we've got a 3-year project. We've got €4.5 million to spend. Let's try something a little crazy and ambitious. And went straight for this and kind of grabbed every bit of research around that we could and tried to push forward with those. And we got some good results too. So information extraction plugs into this, right? When you can pick out an assertion in an article. Maybe the assertion will be something like New York has a population of 2,000. And we've done our named entity linking, right? So we know we're talking about New York in the Empire State. And then, so once we have this, we say, well, that claim in the text looks a bit rough, but computationally, we can pick out that triple. We can go compare it with that Wikipedia info box. And we're like, well, 2,000 is way off. So now we know this is false. We can do that computationally, right? So that's nice. Then we can just spot the liar kind of automatically. But we have a bit of a problem with things that aren't stored in Wikipedia in this case, right? How do you deal with that? And often when news is developing very rapidly, it's not stored there. Or maybe it's something that doesn't hit their notability guidelines or isn't really the right thing for an encyclopedia. So my favorite example of this is we say maybe the town hall is made of chocolate, right? And usually it doesn't say whether or not it's made of chocolate on Wikipedia because that's that folk knowledge that you can't build things out of chocolate. Well, I mean, maybe if you go far enough north, right? But yeah, okay. I don't know about the tensile strength. So with this, if someone puts a claim like this out on social media, which could be Twitter, Facebook, could be a web forum, usually there's someone turns up who's kind of somewhat invested, and we'll just say, no, that's BS, right? That's directly false. Or a few other people, really? Is it true? Is Town Hall made of chocolate? No. Here's a photo. And then maybe eventually an authoritative account will turn up, the local police, I'd like to say, the building is up to code, we've pinned down, we've licked it, it tastes bad, it's not chocolate. So this we can't verify through Wikipedia, but we can verify kind of through the people, right? There's that crowd knowledge there. So to get this, we do something called, we have two processes, right? The first one is stance detection. And with this, you work out from the text someone has written, you work out what their attitude is to a claim. In Theme, we broke this up into, do they support it? Do they deny it? Are they commenting on it? Or are they questioning the claim? And you've been on the web, right? So you can imagine the vast majority would be comments and a little bit of people arguing about how true or false things are. So the pattern of those like support and deny and query and mostly comment responses actually then can be used to predict how true an assertion is. So we built a lot of technology, and for this, it's European Union, right? So it was polite to put in more than one language, maybe even a requirement. So we did this for English and Bulgarian and for German. And we built a system that can work out that stance, right? That support, deny, query, question for any comment given some claim. And then after this, a little bit after the project finished, we then built a system, and this was Ahmed Acker and his guys down at University of Essen and Sebastian Dungs, that's right, where we would the system takes in those sequences of attitudes, so those conversational stances, and it can predict the veracity of the source claim with about 80% accuracy.
So the conversation patterns ranging from support, deny, query, comment, like those patterns over large amounts of data, the sequence of those can then be used to predict whether a claim is true or false.
Right. So it sounds kind of intuitive and also a bit crazy. The way the conversation goes at a very high level will tell you a lot of the time whether the original claim that people are talking about is true or false. And the crazy thing with this is, we've even found very recently that this transfers across language.
That's what I was going to ask, between Bulgarian and English. And
that's cool, right? Yeah, it's really cool. So we found that the pattern of a conversation in English, if we just know from that conversation pattern, and bear in mind, right, it's just those stances, so we don't keep any of the words, so it's a little language independent, right? And if we learn the pattern of conversation around a false claim for English, we can take it over to, for example, Danish, right? Seeing as we're in Copenhagen, and we've done this experiment, you can take it over, and that knowledge will tell you whether or not the ground claim is likely to be true or false. Mm-hmm. So this will work for those really emerging claims where things aren't logged in Wikipedia. And it seems to work. It's two European countries with Germanic languages and culture, so quite close. But I don't know. I'm interested to push this, right? And then we find out some more fundamental things about how humans discuss things and how we socially construct things, like notions of truth.
Exactly. I think that's fascinating. It gets to kind of the core of communication. And I have some questions later about parts of speech and part of speech tagging. But first, honing in on these conversation patterns. This was on Twitter or online forums?
So for this, there was a lot on Twitter, and then also, I guess Reddit's the mega forum these days, right? Yeah. So it's Twitter and Reddit.
That's what I wanted to ask, actually, those two examples, because to what extent are the conversations influenced by the architecture of the platform or the way it's designed? Because I can imagine that the conversation dynamics of Reddit might be a bit different. You have upvotes and downvotes that push things around. You have more indentation, whereas you don't on Twitter. So, have you thought about the design of platforms and how they might have implications for this type of research?
Yeah, absolutely. So it's interesting you mentioned the upvotes and downvotes. So this was something we have always been quite careful to completely exclude from the data. And I guess that's kind of what you only get upvotes on Twitter, right, with the likes.
Or you have this what is it called? The like to comment ratio?
Sure.
Something like if you get a lot of comments but not likes, that's interpreted as a downvote, essentially.
Yeah, humans love just boiling complex things down to numbers and then sticking to those numbers. I don't know if it's a very constructive tendency, but yeah, you're right. That ratio, right? If it's it's a pretty good indicator, I guess. But it might just be that someone who is kind of really easily fooled also has a whole bunch of followers. Maybe they've spent more of their time building a following than doing critical analysis of news, right? And I mean, the latter isn't something that we can spend every hour of every day doing. So maybe that's okay. But this kind of mass attention effect can really distort what people are saying. So we thought we'd kind of just deliberately cut this out. Yeah, and maybe if there's just one or two people there who have an idea of what the truth is, then we'll consider their opinion and feed it to the model and remain somewhat objective. But there's also, right, there's that structure of the platforms, and you do see a really big difference between how people converse on Twitter and on Reddit. And it goes further, right? I mean, there's like Instagram where we see almost, for me being like kind of the old grumpy man I am, these are almost sickeningly saccharine interactions all the time on Instagram, right? People complaining, having a big debate on Instagram. It's not cool. It's not what Instagram's about. We don't do that here, right? So this model, I don't know if it would work for Instagram, but yeah, I don't know. Well, ask me in a year, right, when we've done the experiments. But yeah, we did see, so like you get Twitter models for English for one language would transfer okay to another language for Twitter, but that big problem was getting things to transfer between platforms for sure. Yeah, I mean, the design really nudges the kind of conversation you have. I mean, the solution to that is just take data from both and train them both at the same time. And another thing we saw from Reddit is that you can have quite serious discussions on Reddit without having to tag every message with a little kind of /2 that you're going to reply in a little while, right? And continue it on. You can just add that whole thing, which means you get that little roller coaster, right? Of if you're going to get into a long discussion of some point, some statement, some claim, you might sometimes support it, sometimes query it, sometimes comment maybe on the backstory, and then sometimes deny certain parts of it. Things sometimes have nuance. I've heard. I'm just a computer scientist. I don't know, but right. So labeling, like getting those human annotations of what supports, queries, denies, in terms of Reddit comments was way tougher than tweets. And I think for the system as well, it's a little more complex to fish out what's going on.
Right. Which I guess is also has to do with things like they don't have this character limit, so people can make longer arguments, and that makes it maybe difficult to classify.
Right, it's exactly that.
You can have multiple in one post. So going along this line, let's talk a bit about some challenges for NLP looking at social media data. And the first is, how do you deal with noise? I mean, particularly on Twitter, where you've done a lot of research, there tends to be lots of shorthand, as we were talking about, context-dependent messages. They're littered usually with typos and spellings. So how do you meet this challenge when you're kind of parsing out this data?
So I see a lot of researchers kind of approach this exactly the same way I did, but then I took kind of a really sharp turn a little way after. So I thought, just like you kind of framed the question, that it was noise, and it was it's almost like this kind of Shannon noisy channel thing, right, where we assume someone is trying to talk properly for some predefined gate-kept notion of proper, right? But there's a lot of background noise, and so we can't hear them properly. All we hear is their tweets. And we'd like to work out how that would look in this so-called proper, authoritative, canonical language. And there's even like a whole computational method of this called normalization, right? And you might even build like a little translation system, like a pocket Google Translate, to go from tweet to Charles Dickens, for example. Yeah, what we discovered, I think there's a whole field, but yeah, this was around the time I was kind of looking at it as well. So it was lovely to be on that crest of research, right? When we kind of looked a bit deeper and we thought, well, hang on, actually what looked like noise actually is signal. It's just signal about things you weren't looking for, right? So if someone's included a smiley in there, or can I ask maybe a personal question? If you were to type a smiley, would you include a nose?
No.
All right. So this is quite indicative of you being born after 1980.
Really?
Right. If you stick in the nose, pre-1980.
Huh.
Off we go, right? Was it correct? No, too personal. I won't know.
Well, I'm thinking
you look very young from here anyway.
Well, I'm thinking also like I know Ukrainians, they don't even put the eyes. It's
right,
just,
same with Russians.
Yeah.
They just hold down that closing parenthesis.
3 smiling mouths is greater than 2
right.
parentheses or whatever. Anyways.
Oh, yeah. And I mean, if you go further east, there's this idea that emotion is loaded onto the face through the eyes rather than the mouth. So you just get the eyes, right? So you get 2 little carrots. Shift 6 twice. That's a smiley face. So we had all this information. Well, hang on. If we ignore those emojis, those smileys, then we lose information about the person. There was a slightly... right. So there was this one guy, Ian Stewart. He was looking at gang forums from the US. And he kept seeing there were these people, they couldn't get the 2-letter sequence CK correct, right? They always write luck Lucc. And he was like, well, or lucky, or some other words. And he's like, what is going on, right? So you look and you think, oh, is it just one user? Is there one person who doesn't know how to spell? Are they inconsistent? Do they get it right sometimes? No, they were super consistent, and it was a whole subswathe of users on these gang forums. Like, well, what's going on with this? It seems almost like they're using a different lexicon, right? A different dictionary to the rest of us. And so you dig a bit deeper and you think, well, why wouldn't they use CK? And it turns out CK could stand for Crip Killer.
Ooh.
Right? So, if you would like to think that you're affiliated with the Crips and you're typing on a gang forum and you're trying to show your affiliation, you would never type CK. You always change it to CC. So then we have all this demographic information about the person, right? We probably know their gender, their age, their education level, maybe a rough thing about their location, right? It's probably not going to be inner city coastal, and it's probably US.
Interesting.
Right?
I've heard about this in the context of these forums like 4chan and 8chan, where seniority or being in the know, how, whatever respected you are in the community, because it's anonymous, people do have all these, putting extra periods or spaces at the right point. Have you gone into that or know anything about that?
We haven't gone into that too much. I think that's really
probably
neat.
For the best.
Well, but for who, right? I reckon, this sounds like something that could be just mined trivially. Mm-hmm. If you build a model of how language looks in general, maybe we take all of Twitter and all of Reddit, because we can get those data sets. I don't know how fast your internet is, but we could have those by Monday, right? Or 20 terabytes of it. That'd be enough. And then we can build a model of how people speak on social media. And then we look at all those 4chan's posts and look for the ones that are using punctuation in a weird way, right? Where it's statistically unlikely that it's a mistake or a variation from the central thing. And then they'll all stick out. And we'll just get this list of all the posts with people using all these dog whistles, if you like. But kids are going to be kids, right?
Right. Well, maybe that's another European project you can you can start next. I want to ask, what's your take? Speaking of noise and Twitter, what's your take on the extension to 280 characters? Has that somehow produced better data for you to use in terms of eliminating noise because people can have longer posts?
That's a nice question. The data's richer, and it's going to be easier for the tools we had before. People can get in longer sentences, and people don't have to condense themselves down to an ultra-tight summary. Is that a good thing? I don't know. I mean, editors are always telling me to make my sentences shorter, right? Get it nice and snappy. And then if we don't see how humans summarize things really tightly, then we don't get an opportunity to learn how it's done. I think there's like the gut intuition, right? That we'd see a lot of really kind of maybe even grotesque to some shortenings of words with that 140 character limit. But actually, these were really super rare on Twitter. You wouldn't see them very much. And there's almost this concept of Bayesian surprisal going on, which is something we know humans and machines both have. A kind of rough explanation is we'd have this model of how likely something is to be. So like if I look at a bush and it looks kind of round and green and a bit noisy, I guess that's pretty much like a bush. But if you see something that doesn't look like how you expect, then your attention is drawn to it. And it seems to take a much bigger place in your kind of idea of what's significant, even though it's very rare. So maybe one semi-classical example of this is if you go to a Northern European country and you do a survey on how many Muslims there are in the country and how many people wear burqas, right? And a lot of people wouldn't have grown up with these kinds of things around. And so they would expect the world not to contain them. So when they do see someone going to mosque or they see someone wearing a burqa, this is very surprising to them. And we have that cognitive bias where humans just attach a whole bunch of importance to it. And I think it's just exactly the same with the kind of hyper noisy stuff on Twitter, right? You see that little thing, you think, this is a disaster. It happens super rarely, super, super rarely. And I think probably it's going to continue with the 280 character limit as well, right? People love to represent themselves. You lose so much when you can only type to a person, It's not just that you can't get their pheromones in your nostrils and really, have a human-to-human interaction. You just lose so much. So people love to do that expression. And that shortening, that semi-grotesque to some typing is just a phenomenon of that.
I want to return to that idea, but I have two more questions for you. And one is about part of speech tagging and the sort of the relevance of that, because kind of how you were saying with the conversation patterns, they can be relatively stable across languages. Is it the same for part of speech and the way that those are phrased? And so kind of like I've been doing a little bit of this research myself. I'm not so well versed in it, but part of speech tagging seems to be particularly useful way of analyzing this text as data.
Nice. So part of speech tagging is kind of this really fundamental task in natural language processing that a lot of other things build upon. And what it does is just tells you the role that each word is playing in a very coarse way in that sentence. Like this word is being a noun, so it's describing a thing, a concept. And if we don't have that information, it's really hard to connect all those words together. Maybe the next step would be something like parsing, like a dependency parse. And this would be where we work out kind of which words linked to which other words and what that link means, right? The red fish, so now we know the word red would modify fish, doesn't modify anything else. Oh, like that example we had earlier on, a dependency parse would be able to disambiguate natural language processing, right? And then we'd know that we're processing natural language, right, instead of the other option. So then it's really handy. And another thing, part of speech tagging, so because it's so fundamental and relatively easy to frame and kind of somewhat simple to build an evaluation system for, so it tends to be one of the first things people look at in NLP in an adversarially noisy environment, like Twitter, for example, right? We used to how English looks if we've only read the Wall Street Journal, which is what a lot of English NLP is biased on, right? It's this kind of newswire from the 90s and with all the biases that come with that. And so once you kind of build your model of language, but then you step out of this and you're like, whoa, people in the real world talk nothing like this. And in fact, I've done a lot of the work annotating and working with this. And I wouldn't be surprised if we saw the majority of Wall Street Journal announcements that we would get in the 90s would be completely automatically written now. Just because the language is so regular. It could even have been automatically written for 20 years. I don't know. People don't talk like that. So then all the systems that we've built, we find out they suck. They fall to pieces. It doesn't work anymore. So then you have to start right at that fundamental level and look at tweets and try and do some part of speech tagging there and build your way back up. Which
I guess, taking a bit of nuance into that, you could, I guess, use that as you're giving the example of the crypt killers and luck, that you could perhaps look at different communities on Twitter with different vernaculars, I guess, and maybe use part of speech tagging to identify communities within the data.
Right, for sure. Yeah, that's a nice idea, yeah.
Interesting. Yeah. So my last question has to do with non-text. And you were talking about expressing yourself on Twitter, given the limitations. And, we see a lot of GIFs and memes that are going around. So my last question has to do with images, video, deepfakes, sort of moving into the future. Where is the research in terms of determining the veracity of these non-textual forms of media?
That's a good question. So for me, I would say, being an Englishman, like the inventor of the file format, I'm one of those horrendous people who always says GIF.
You're one of the 15%. So we ran some surveys. My friend works at a polling company. We ran nationally representative surveys and we did a Twitter poll.
No way.
And both converged. I think Twitter poll was 77% say GIF, and the U.S. national representative survey said 85% of people say GIF. So you are in the minority.
Well, that's cool, dude. I thought I was in like the 3%. So we're winning. You're going down.
But right? the maker of the format prefers GIF.
The CompuServe GIF.
Yeah.
Yeah.
It's also peanut butter in the US.
Yeah, sure. And it's like a house cleaning fluid in the UK. I think called SIF now. So the graphics interchange format, that's too much of a mouthful. Let's say video. So spotting fakes actually is kind of super easy. Just humans suck at it. So coming from NLP, I'm just going to rip the whole question, put it at that origin point so I have something grounded where I know what I'm talking about. And that is, we found when you're generating text, it's pretty easy to get to a point where you can fool a human. This was something, actually there was research at University of Copenhagen, I guess 4 or 5 years ago, with Dirk Hovey. And he found actually these reviews, when they're auto-generated, are super easy for computers to spot. And that kind of makes sense, right? Because you can look at the words, look at how they're used, and if you count everything up, you measure those probabilities, and you compare them with how humans speak and what would be artificially stable and reliable, almost too perfect, then it'll fit the too perfect model. And it turns out you can map from there to pixels and lines and how they're all drawn, right? You can often tell by a few of the pixels, once you've observed a lot of these videos that are natural, and you've seen some of the artificial ones as well, it's really easy for computerized systems just to say, no, this is one of mine. Whereas it's unreasonable for humans to go and count all those pixel values and measure all of it and kind of see the temporal dimension as you go frame from frame, where all the changes are. We have no hope of doing this. Our eye isn't designed to do that. And I mean, there will be a lot of visual information to receive in a format you don't want, right? As pixel color values. You don't want that anyway, so that's okay.
Well, as customary by now on the podcast, the last question is not the last question. One last follow-up, which is, of course, this is getting speculative, but looking at like Facebook and how they're planning to address some of these issues, and basically their argument is that we're developing AI to do this, but it's very difficult. Whereas you're saying it's kind of the opposite, where it's the AI should be able to detect it, whereas the humans are having the difficulty. So I'm thinking about content moderation, humans versus machines. Do you think machines are the answer rather than humans?
So content moderation is it's a broad umbrella, right? And we can put in there, let's put two things in there, right? Let's put in those synthetic things like we were just talking about, and let's put in content that really shouldn't be there. So the synthetic things, that's okay. You can pick this up. It costs money in terms of hardware, and will burn down the earth generating the electricity to run it. And a simpler solution for Facebook is to close everything a bit more, get everyone in groups, make sure everything's shared privately so there are no complaints. Yeah. For the stuff that shouldn't be there, I mean, this is trickier. This is a really tough problem. So I was talking with someone from a Danish NGO, Digital Responsibility, and they'd been dealing with a lot of kind of videos, intimate videos that have been shared without everyone's consent. And so if you're going to get how can you tell digitally whether or not a video or a bit of voice recording was made with consent? This is tough, right? I mean, you can't ask an annotator, was this made with consent? Because we don't know. There's that wall of intentionality, isn't there? What did the person mean when they performed this act? We don't know. So that is super tough. I would completely agree with that statement from Facebook in that regard. The fake stuff, but the rest, that's difficult.
Interesting. Well, that was my last question. And Dr. Derczynski, thanks so much for taking the time out and coming on the pod. It's been great.
Thank you. What an honor.
I've just been speaking with Dr. Leon Derczynski, assistant professor in computer science at the IT University of Copenhagen. And that's another Social Media and Politics podcast in the books. Thank you so much for listening. Remember, you can follow us on Twitter at SMNP Podcast. You can also check us out on the web and sign up for the newsletter at socialmediaandpolitics.org. I'm your host, Michael Becerra, signing off from Malmo. See you next time.